When we think of black holes, we picture something powerful, eternal, and all-consuming, a cosmic entity that traps everything, even light, within its gravitational grip. But what if black holes weren't eternal? What if over time they could shrink and disappear entirely? Today we're diving into the mind-bending theory of Hawking radiation and what it means for the ultimate fate of black holes. It was in the 1970s when Stephen Hawking proposed something groundbreaking, a theory that turned our understanding of black holes on its head. Hawking's idea was that black holes aren't completely black after all. Instead, he suggested that they emit a faint glow of radiation. We now call this Hawking radiation. But how is this possible? To understand Hawking radiation, we need to look at something strange called quantum fluctuations. According to quantum mechanics, empty space isn't truly empty. Particles and antiparticles constantly pop in and out of existence. These pairs typically annihilate each other instantly, vanishing as quickly as they appeared. However, when these particle pairs form near the event horizon of a black hole, something fascinating can happen. One of the particles may fall into the black hole while the other escapes into space. The particle that escapes becomes what we detect as Hawking radiation. And here's where it gets interesting. When a black hole emits Hawking radiation, it loses a tiny bit of its mass. So, over time, as a black hole continuously emits Hawking radiation, it slowly loses mass. It's a gradual process, but theoretically, if a black hole continues to emit radiation, it could eventually shrink down to nothing and disappear entirely. This process is what scientists refer to as black hole evaporation. What about the information? But there's a problem, a big one. If black holes can vanish completely, what happens to all the information they've absorbed? The star systems, planets, gas, dust, and even light that have fallen into the black hole. Where does that information go? This question is known as the information paradox. In physics, information is more than just data. It's a fundamental part of understanding the universe. Quantum mechanics tells us that information can't be lost, even if it changes form. So, if a black hole vanishes, does the information it absorbed go with it? Does it somehow escape in Hawking radiation, or is it lost forever? Scientists have proposed various theories to solve this paradox. Some suggest that the information is encoded in the Hawking radiation itself, though no one has figured out exactly how that would work. Others think the information might remain on the event horizon as a sort of hologram, a theory called the holographic principle. And still, others believe we may need an entirely new theory that unites quantum mechanics with gravity to answer the question. What do you think? Could black holes really vanish completely, or do they leave something behind? It's an open question that could redefine our understanding of reality itself. If Hawking radiation turns out to be correct, it means black holes aren't the eternal cosmic prisons we once thought. Instead, they're temporary objects slowly evaporating and giving back to the universe. This fascinating theory combines the mind-bending ideas of quantum mechanics with the intense gravitational world of black holes, proving that our universe still holds many mysteries waiting to be unraveled. Thanks for joining us in exploring Hawking radiation and the potential fate of black holes. In our next video, we'll dive into wormholes and the possibility that they might connect different universes. Don't forget to subscribe so you don't miss out, and share your thoughts below. What do you think happens to the information inside a black hole when it evaporates?